This lesson is looking at types of chemical reactions. There are 6 different types of chemical reactions that we will be studying, and they are classified based on the rearrangement of atoms that occurs during the reaction. The first type of reaction is called a synthesis reaction, and this is when 2 or more substances join together to form a new compound. So synthesis means joining. So combination of 2 substances to form one new compound. And this is the skeleton equation for what a synthesis reaction would look like. It's just showing 2 substances joining together to form a compound. And A and B, the substances that join together, can be either elements or they can be compounds themselves. Looking at a couple of examples, we can have hydrogen and oxygen joining together to form water. So hydrogen and oxygen, as you know, are both diatomic molecules, meaning that they always exist as H2 and O2. So we can have hydrogen joining with oxygen to form water. That is a type of synthesis reaction. Another example involving compounds is having calcium oxide, CaO, and water joined together to form CaOH2. 2 compounds joined together to make another compound. Second type of reaction we will be looking at is something called a decomposition reaction. When something decomposes, you know that it breaks apart. So this is when a compound breaks apart into either individual elements or into simpler compounds. So a compound breaks apart. This appears as a skeleton equation exactly backwards of a synthesis reaction. So we have AB joined together as a compound here, breaking apart into A plus B. 2 examples here. First one is the water one going backwards, so starting with H2O, breaking down to H2 and O2. Another example is you could have H2CO3. Here's a compound that's going to break down into 2 simpler compounds. So it's breaking down, but we still have compounds in the end. So this is the opposite of synthesis reaction. It's a decomposition. H2CO3 goes to H2O and CO2. Third type of reaction is something called single replacement. And this is when an element reacts with a compound and one of the elements in the compound is replaced. So an element reacts with a compound and one of the elements is replaced. Here we have AB, a compound, plus C. C is going to come in and replace B. B will then be kicked out. Or actually, we're going to have C replace, this won't erase. C replace A. So C will come in, replace A. A will be kicked out. And then you'll be left with CB and A. So A will be left on its own. An example of this is having aluminum reacting with iron oxide. The aluminum can come in and kick out the iron. It's always going to be that the element that's by itself, and this is usually a metal, usually not always, but usually, will go and kick out the other element that is like itself. So a metal will replace a metal. If this was a non-metal, it would replace the non-metal. So aluminum, because it's a metal, is going to kick out the iron. Then we get iron by itself and aluminum joined together with the oxygen to make aluminum oxide. So that was single replacement. Double replacement reaction is the same thing but with 2 compounds. So you have AB and CD. The C and the A swap places. So there is a switching of partners, and you get CB and AD. So two compounds react, and two elements replace each other. So two compounds react, and two elements replace each other. So we can say that they switch places, or switch spots. An example of this would be if you had iron chloride and potassium sulfide, two ionic compounds. The Fe and the K can switch spots. And when we do this, we need to be aware of the iron charges. We're going to end up with FeS and 2KCl. So the iron and the potassium, both being metals, have swapped places. Fifth type of reaction is something called acid-base neutralization, or you may hear it called just neutralization reactions. This is when you have an acid and a base, and they result in a neutral solution. So an acid neutralizes a base. Acid neutralizes a base and results in a neutral solution. And the general formula for this is you always have an acid and a base. You always form a salt and water. So for example, here we have a really common acid and a really common base. This is HCl, hydrochloric acid, and sodium hydroxide. And the H will replace the Na. So we're going to get NaCl and H2O. NaCl is our salt, H2O is our water, and that's an acid-base neutralization. It's really just a type of double replacement reaction with H plus and OH negative. Last one, number 6, is a combustion reaction, and this is when an organic substance reacts with oxygen and produces carbon dioxide and water. So organic substance reacts with oxygen, and produces, the products are always carbon dioxide and water. So this is something organic, has to have carbon and hydrogen. So this is just could be any organic compound, and it's going to react with oxygen to form carbon dioxide and water. So for example, we could have C3H8, it's an organic compound, and it's going to react with oxygen. The products are going to be carbon dioxide and water.